we're going to do some interactive work. You should have downloaded QGIS, and we're going to use that to create some maps. You don't need any experience. We will do everything from scratch. GIS stands for Geographic Information Systems, and there's tools for storing, analyzing, and visualizing data that has a location on Earth. It combines location, attributes, and visualization. GIS helps us understand where things happen and why that location matters. Why is GIS useful for natural history? I've got a few key applications written out here, such as mapping species distributions from museum collections, visualizing uncertainty in georeference records, and supporting digitization, curation, and research workflows. What kind of data does GIS use? Vector data consists of points, lines, and polygons. Points can be used for things like specimen localities, observations. They're basically just point coordinates. There are also lines, which are things like rivers, roads, etc. Polygons can be things like country boundaries. It could also be your house at a different scale, but it's more like larger shapes. Raster data is continuous surfaces. So raster data usually looks like little pixels, and it's often seen in satellite imagery and basically continuous grids for temperature, climate, vegetation. But today we will work with vector data. We have two kind of data sets that you should have downloaded. We have a geo package of myriapoda data. Myriapoda, if you're not familiar, is like centipedes. And then we have a shapefile of the Germany administrative polygons. A shapefile is a collection of files that has to stay together. It's very common for vector geospatial data. If you unzip the file, you might have seen there are lots of files inside it. And they have different extensions like .shp, .shx. We're going to focus on the DEU admin 1 layer. The 0 is just the outline of Germany, and then 1 has the outline of all the states. Click on New Empty Project. Find the SHP file. Drag that into the dataset. Into the layers. Your colors might be different. It's totally fine. It just defaults to whatever it likes. You want to right click on the DEU admin 1 in the layer in the box that says layers and click zoom to layer. Another tip is that you can rearrange the layers in the layer panel. Germany might be covering all of your points now, but you can just drag it below the point file. And then you can see your points a lot nicer. In the toolbar, the button that says pan map, and you can drag your map, pan around if yours hasn't defaulted to that. It's just a bit easier to navigate that way. We can choose a layer, either of them, right click on it and click open attribute table. And then you're going to get this table with all the data from the features. Here we have all the points and the data that's associated with them. We have the coordinates, which is what the GIS is reading, where they're popping up. But we have other information like the country, the uncertainty, the altitude, and the collector who collected the myriapoda in that location. You can also right click on the attribute table for Germany and it will give you the list of states because that's what we're looking at. You might have zoomed in on Germany and seen that it looks a little bit funny in this projection. This is because of the projection that we're using. There are many different map projections. Basically, when you move away from the equator, the projection that points are currently in get a bit distorted. That's something to keep in mind. If you don't like looking at it like this, a little bit like off what you're used to seeing on maps, you can change it. You can change the projection. At the bottom, there should be a little button that looks like this. You can change it to UTM Zone 32 North, which is a projection that's more focused on Germany. If you're looking at the rest of the world with this projection, it will look really funny, but Germany will look more like how we're used to. Changing the projection will change how you view the data, but it doesn't change the actual data. It's in the bottom right, just here. And then you will get this pop-up box. And you can type in UTM Zone 32. And then you should get this one, but you can type it in the filter to find it. And then apply. Now we'll have a look at geoprocessing. Geoprocessing is the set of tools in GIS used to analyze and transform spatial data, such as clipping, merging, dissolving, intersecting, or calculating areas and distances. In natural science, geoprocessing lets us combine, filter, and analyze specimen locations with environmental or administrative layers to answer spatial questions. Let's take a look at one geoprocessing tool, which is clip. You have an input layer, and then you have a clip feature, and it will clip the input to the extent of the clip feature and give you a new output. And the new output is a new layer that you can use in the project or in future projects. We're going to clip our data to only keep the points in Germany. You want to go in the top bar to Vector, Geoprocessing Tools, and Clip. And then a box like you see on the right will pop up. Vector, Geoprocessing Tools, Clip. And you're going to input the WiNoDa. We want to clip the points to the extent of Germany. So we don't want to see all these points in other countries. We just want to focus on Germany. The input layer is the WiNoDa. The overlay layer is the German admin one. And then run that. And a new layer should pop up. In the layers, it might be under your other layer, so you might have to rearrange your layers to see it. But it should be a new point layer with probably a different color of points. Untick the WiNoDa all. We won't use that anymore. You can move it to the bottom and then rename the clipped one. I'm going to rename mine to WiNoDa _ Germany. You just right click and rename it. So just deselect the WiNoDa layer, the all layer, rename the new layer. It's currently just a temporary layer. You can right click and make permanent if you want to save it for the future, but we can just work with it as a temporary layer for today anyway. Right click on WiNoDa and then go to Properties, Symbology, and choose a simple marker. Right click on WiNoDa and click on Properties on the German one, on the new clipped one, not on the old one that we're not looking at anymore. And then this box should pop up. Click on the symbol marker. Change the color, the fill color and the outline color. Open this and change it to whatever color you like. Apply to see the changes. If you look at somewhere like Berlin, if you go back to color, change the transparency, and that will show you areas with more dense points a bit clearer because they come through the other layers. And you can change the point size in the size box and go up and down or whatever you like to make the points whatever you think best displays the data. You can change the DEU admin layer in the same way. Right click Properties, change the stroke of polygons to white. I think this just makes it a bit cleaner in the map. Change those however you like. I want to save it permanently. Make sure you put in a file name and like a path to save it. I am in UTM zone 32N, which is EPSG 25832. Your points don't have to be all the same color. What we can actually do is color them based on the collector. I will say right now this data set is maybe not the most ideal to do that because there are a huge amount of collectors and the data is not quite clean. So some collectors' names are written in two different ways and some are a bit uncertain. But from the data that we have in the attribute table, this is probably one of the most interesting to color code. We will use it for this example. What you want to do is open the Maria Poda properties again in the symbology. And at the top here, you can see it says single symbol. Change this to categorized. The value that we're going to categorize by is the known collector. Use random colors and click the button that says classify, and it's going to give all of the collectors a different color. You can shuffle the colors, make them different. You can pick a spectrum, although this data isn't really something you'd want on a spectrum. You'd want more random colors. If you really hate a color, you can still click on that individual color and change it. If I say I actually want this guy to be red, I can do that. But basically, once you apply it, everyone will have their own color. As you can see, though, there are quite a lot here, so some of the colors are hard to differentiate between. And like I also said, the data is not completely clean. One thing you can do is sort by the value and have a scroll through it. I know there is Heinrich Dürkob and Heinrich Dürkob with a question mark. We can assume those are probably the same person. We want to click on those, like highlight both of those, right click and merge the categories. So it will give them the same symbol. Same with Karl Wilhelm Verhoef, he has two as well, so we can merge him there. We could go through and do it for all these other question marked people, however, we don't need to. I just want to give you an idea of this being like another feature you can use. I want to make my points a bit smaller now, so I will go in there and change that. We can see our colorful map with all different points there. This can be like a very useful way to display different information. You can see like some areas where some collectors focused on, like there's a lot of pink on the northeast and the north of the country. At least in my map it's pink and yours is probably something different. Identify features. Click on this and then click on a feature. You'll get the specific information. If you click on this yellow feature here, you can see it's referring to Frederick Dahl as the known collector. If you use this info button and then click on a point, it will give you all the information about the point. And then I'm going to go back to my panning hand just because I find that easier to work with. When you have geospatial data, there is often uncertainty associated with it. For example, we know it was collected from this area, but we're not sure if it was exactly at this point or maybe 300 meters the other direction. We're just not quite sure of how exact the point is. We can express that with uncertainty. And the uncertainty data in our data set is in meters. What we want to do here is to change the size of our points to show the uncertainty. It won't be exact as our data is not in a metered coordinate reference system. It's a bit complicated to explain, but basically we just want to break it down so that the points with less uncertainty are smaller and more precise. The points with more uncertainty are bigger. they take up a bigger area because we're not sure exactly where they are. It could be in a bigger area. Go to properties and change categorize now to graduated. The value here will be the uncertainty, and the method will be size. Click classify. So there are different modes that you can do this in, but the best mode here I think is equal interval, which means that all of our data is split into one of 5 categories here, and the size of the categories is the same. So there aren't the same amount of points in each one, and then use as many classes as you like, and the few outliers will be larger. A few large circles show that they may be anywhere in that space. For example, if you put them at equal count, there will be an equal number of points in each zone. If you apply that, you'll see like more of the larger points as well as the smaller points show up on the map. Once again, go back to our properties. We're going to change the method to color rather than size. We'll have a color ramp. The lower value should be lighter to the darker, higher values. I'm going to change mine to green. I would avoid rainbows just because it's not so clear which is like lowest and highest, but just kind of one spectrum is fine. Greens, blues, grays, reds. And I'm going to make it equal count this time. You can choose what you want here. Again, have a play around with it. Equal count puts the same number of points in each group. Change the value from uncertainty to altitude. Otherwise, it's not going to make much sense. Then click classify again. You can do more or less classes if you want to show some areas better. If you do equal interval, it will just show you that the higher elevation areas are definitely in the south and on the southeast borders, but you can't see so many differences between the rest of the country because it's quite similar in value. That's why I decided equal count was maybe more interesting to display. Each group has the same amount of points, but it is like more of a logarithmic scale. There's not the same amount of difference between the first and second level and second and third level. We want to figure out how many points fall within each state in Germany. We are going to go into vector. Vector is on the top bar here. And then we're going to scroll to Geoprocess. It's in the analysis tools, so the very first one. And then count points in polygon. Click on that. And we're going to get this pop up. And our polygons are, of course, the German admin layer. And the points are the Maria Poda, Germany. We're going to leave the rest of it blank. The count field name should be the default num points. And then we're going to run. Once we run it, you're going to get a new layer like this pop up on top. This is again a temporary layer, which you can make permanent if you want to, or just leave it temporary, it doesn't really matter. It's just called count. Right click and rename layer to Germany count. To make sure it did it properly, right click on this and open the attribute table. The attribute table should be the same as the German layer attribute table. However, it should have this extra field called num points, which is the count of the points in that polygon. Right click on our new layer, whatever you've decided to call that. Properties and symbology. Then instead of single symbol, choose a graduated symbol. Set the value to num points or whatever your new count field is called. Pick a color ramp. Then set the mode. Natural breaks can be good in this kind of natural history data because it's uneven data. And then classify, choose as many classes as you like. Apply that. And that should update your map to indicate how many points were found in which state. Once you've done that, on the left of this property thing, there's another button that says labels. Click on that, and at the top, change it to single labels. And the value will be the name 1, which is the state name. You can change the font size, put a little buffer so you can see against the different colors what the name is. And then you have a nice choropleth map label with the different states. To display our map, we are going to put it all together and create a simple print layout for export. We want to turn these maps into something we can print out and use. In the top left, click on Project, New Print Layout. Give it a title, WiNoDa. And an entirely new window is going to pop up. On the bottom right, the page orientation and item properties, I'm going to change to portrait. It just fits a bit better. Click on this button at the top, add item. I'm going to add a map. And then I'm going to draw how big I want my map to be. It's going to give me the map that's open in my other window. In item properties, click on interactively edit map extent and zoom in and adjust my map to the size I want it to be within that box. There are a few important things we need on a map. One is a title. We're going to add another item, which will be a label. There's a text field, basically. You're going to give it in item properties, change the text, give it a nice, meaningful name explaining what it is. Don't call it my map, please. Give it a nice name explaining what people are looking at. Change the size. Add item and add a legend and put it in the bottom. It's going to show us all the legends for the data, but we want to make it only what we can see on this map. In the item properties, there's this legend item box. Scroll down, it says only show items inside linked maps. I haven't turned my background layers off, so the Mariaputa Germany is still showing up. But if I turn that layer off, that would disappear. And then we want to put a scale bar in. So add another item and add a scale bar and add a north arrow. One more thing we can put in here is like a text box with your attributions. Go back to the QGIS layer and change what we're looking at. I don't actually want to display the Germany count on here. Update this. Put a different map on here, add item map, and then it would be my map that I have open.